So today we're going to look at the area of composite figures. And composite figures are figures that are not of the common typical shapes. They're composed of several different shapes combined together to create a unique figure. So I'm going to shade in a figure and then we're going to find the area of it. Okay, so let me show you an example. Okay, so the yellow figure. So I'm going to draw or shade in a yellow figure. Okay, and what we're doing is we're counting the blocks. Now, because I'm doing this on graph paper, each block I'm going to call it a unit, and I'm just going to say units squared. No inches, no centimeters, no feet, okay? So what I do is I'm going to start counting up how many units squared this area is. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So that would be 21 blocks. That's 22. And then I have half a block here and half a block here. So together, those two make one more. All right? So together on this region, I have 21 units squared. And in this top region, I have 1 here. And then this half and this half together make another whole. So that's 2 units. For a total of 23 units squared. All right, so that's the idea. You break it up into pieces that you know. Now, we don't always have graph paper to do this. So one thing you're going to have to do is identify the shapes that you have. And you would have just said, oh, I see this is a rectangle. And I know the formula for area of a rectangle, right? That would have been area equals length times width. And then you recognize that you also have a triangle here. And you know the area of a triangle. That area is going to be length times width divided by 2. So then you can actually use the formula for area that you know, and then just add the two answers together. Okay? All right, so let's look at example 2, an application of this. Find the area of this portion of the basketball court shown. Cutting it into less words. Find the area of this basketball court region. All right, so here's the region that we're talking about. The basketball court has a circle, and then it's got a rectangle kind of sticking off to the side. And it's giving us that this has a diameter. The rectangular piece is 12 feet tall, and from the center of the circle to the end of the rectangle, it's 19 feet. So, what are the ideas? What shapes do you see? How would we get the entire area, the region inside of this whole court? Right, so if you're thinking that you see a circle and a rectangle, you're partially correct. But the area is not going to be the sum of a circle and a rectangle. Because if you think about it, I were to take this circle, I'm left with this figure here that's got a big curve cut out. This is not a rectangle, okay? You end up with a weird shape that's got a curve on it, so we cannot say that it's going to be a circle plus a rectangle. Instead, you should have noticed that it's actually a rectangle here, this whole thing, plus an additional semicircle. So that's the idea. So we're going to add a semicircle and a rectangle together. Okay, so really you can actually, and just for the sake of explaining this, I can actually take my whiteout pen and ignore this line here. Just for the idea that we are not going to worry about that line because we see it as a semicircle and a rectangle. So let's go ahead and write that down. Area of semicircle plus the area of the rectangle. Okay. So the area of the semicircle is going to be the entire circle, which would be pi r squared. But remember, we only want half of the circle, so divided by 2. Plus the area of the rectangle, which is length times width. All right, now we're ready to use that formula in my expression. And I need a radius. I don't have any measurements labeled on that circle, but can I find them? If this height is 12, this other height on the other side of the rectangle should also be 12. Not only is that the height of the rectangle, it's also the radius of the circle. So this whole thing is 12. So I'm also going to assume that if that diameter is 12, then that means my radius equals 6. Okay? So the radius is 6 on each side. And so I'm going to go ahead and plug that in now. So pi times 6 squared over 2 plus my length, which is 19, times my width, which is 12. Pi times 36 divided by 2, 36 by 2, that's 18. 18 pi gives you 56/52. I divided these first. 36 over 2 is 18, then multiplied it by pi. And 19 times 12 is 228. And the sum of those two equals 284.52 feet squared. All right. Now, anytime you have composite figures, each problem is going to be different. They're not all going to be the same. And your job is going to be to identify what are the shapes that you see. So let me just give you some examples of formulas that we need to recall. So the area of a rectangle. Sometimes it's base and height, length and width, depending. Since it's flat on my table, I'm going to call this length and width. If it was up on the wall on a whiteboard, I would call it base and height. So the area equals length times width. Now, area of a triangle. You have your base and you have your perpendicular height. So area is going to be base times height divided by 2. And then we have the area of a circle with your radius. Area equals pi r squared. Those are the main ones. Okay. All right, so I have these shapes here so we can practice some ideas quickly without taking too much time. So we see this figure, which is clearly not a common figure, but I also see different shapes within there. And you can split this up however you want. You can think of this as a triangle here, and then a rectangle in the middle, or just one entire parallelogram. So it's up to you. So the way I do it is not the only way, but this is just a way of visualizing how you can strategize and think of these things. So I see a triangle here that's 3 by 2, and I see a parallelogram here, which is a quadrilateral all the quadrilaterals are the same formula, base times height. So the base would be 5, and the height of this would be 2. All right, and then I have a regular rectangle here. That's a 5 by 2. So I'm going to go ahead and write in the areas. So 5 times 2, I know this is 10 for this region. And then this is also 10 for this region. And then 3 times 2 I know is 6, but since it's a triangle, the formula is to divide it by 2. So that's going to be an area of 3. So this entire figure has an area of 23 units squared. All right. Now the next one looks like I got a rectangle in the middle and 2 semicircles. Now if I were to bring these 2 semicircles together, I know that I have a circle. And by looking at the diameter here, the diameter is 2, not drawn to scale. And so that means my radius would be 1. So I would have a 2 by 3, that would be 6 units in there. And then the circle together would be 2 times pi times 1 squared. So it would be 6.28. So together that would be 12.28 units squared. All right. It's bugging me. And now the next one, that one looks like a rectangle and a triangle together. That rectangle is a 3 by 4. So that would be 12 units squared. And then this triangle is 4 by 2, which would be 8, but since the rule of a triangle, you have to divide it by 2, which means this is 4. And 12 plus 4 is 16. Okay. And now the fourth one. This fourth one looks like it's got a semicircle and a rectangle in it. However, I only want this region. So if I were to consider the entire rectangle, I would have too much. I would have to remove this curved region out of there. So the idea is going to be we take the entire rectangle and then we're going to subtract what area of it, and then we're going to subtract from that area the semicircle. All right, so area of the rectangle. So first of all, the dimensions would be a 4 by 6. So the entire rectangle is 24. But I don't want the entire rectangle. I want to get rid of this semicircle. And that semicircle has a radius of 2. So the area of a semicircle is going to be, we know this is 24 so far, pi times 2 squared. And since we want half of the circle, I got to divide it by 2. So I'll have 24 minus 2 squared is 4, divided by 2 is 2, and 2 times pi is 6.28. So 24 take away 6.28 is 1772. For that region. All right, so again, there's no wrong answer. You can split up the figures any way you want. As long as you are accounting for all of the spaces and using the correct formulas, you should be good.